Hello friends, in this video we shall learn how to solve the indeterminate problems by using L'Hospital rule. In this video we shall see indeterminate forms of the type infinity by infinity. What is the infinity by infinity type? Suppose fx equal to infinity and gx equal to infinity as x tends to a, or as x tends to plus infinity or x tends to minus infinity. Then fx by gx assumes the indeterminate form infinity by infinity, which can be evaluated by L'Hospital rule. The L'Hospital rule is limit x tends to a of fx divided by gx equal to limit x tends to a of f dash x by g dash x, or limit x tends to plus infinity of fx by gx equal to limit x tends to plus infinity of f dash x by g dash x, or limit x tends to minus infinity of fx by gx equal to limit x tends to minus infinity of f dash x by g dash x. Now, for second derivative also this case happens. Limit x tends to plus minus infinity of fx by gx equal to limit x tends to plus minus infinity of f double dash x divided by g double dash x. Similarly, for nth derivative, limit x tends to plus minus infinity of fx divided by gx equal to limit x tends to plus minus infinity of fn x divided by gn x. These are the forms of indeterminate form. Dear friends, if you have not subscribed the channel yet, please subscribe it and don't forget to press bell icon so that you can get updates of this channel. Now we shall try to solve the examples based on indeterminate form of the type infinity by infinity. Evaluate limit x tends to infinity of x raised to n divided by e raised to n. Here fx is x raised to n. If we put x equal to infinity, it becomes infinity raised to n is infinite, and gx equal to e raised to x. If we put x equal to infinity, it becomes e raised to infinity, which is again infinity. Therefore, this is a infinity by infinity form. Therefore, we apply L'Hospital rule n times, that is, limit x tends to infinity of x raised to n divided by e raised to n equal to limit x tends to infinity of nth derivative of x raised to n divided by nth derivative of e raised to x. We are applying derivative to numerator and denominator separately. That is nothing but nth derivative of x raised to n is n factorial and nth derivative of e raised to x is e raised to x. Therefore, this becomes limit x tends to infinity of n factorial divided by e raised to x. This becomes n factorial by infinity equal to 0. N factorial divided by infinity equal to 0. Therefore, limit x tends to infinity of x raised to n divided by e raised to n is 0. Our second example is evaluate limit x tends to infinity of x divided by root of 1 plus x square. Here, fx is x and gx is root of 1 plus x square. F at infinity is infinity and g at infinity is also root of 1 plus infinity square. It is again infinity. Therefore, this is infinity by infinity form, and hence we shall apply L'Hospital rule. Limit x tends to infinity of x divided by root of 1 plus x square equal to limit x tends to infinity of derivative of x divided by derivative of root of 1 plus x square. Derivative of x is 1 and derivative of root of 1 plus x square is 1 by 2 root of 1 plus x square into 2x. That's why this becomes limit x tends to infinity of 1 divided by 2 root of 1 plus x square into 2x. 2 get cancelled, and simplifying this we will get limit x tends to infinity of root of 1 plus x square divided by x. Again, this is infinity by infinity form. Here fx becomes root of 1 plus x square and gx become x. At infinity, both functions become infinity. Therefore, this is infinite in infinity form. And hence, applying L'Hospital rule again, we will get limit x tends to infinity of d by dx of 1 root of 1 plus x square divided by d by dx of x, which is limit x tends to infinity. Derivative of 1 root of 1 plus x square is 1 by 2 root of 1 plus x square into 2x divided by 1. Again, it becomes limit x tends to infinity of x divided by root of 1 plus x square. We can see that this is the original function. What to do in such cases? When we will get original function after applying sometimes L'Hospital rule. In this case, we introduce a new variable z by substituting 1 by x square equal to z. Therefore, limit x tends to infinity x divided by 1 plus x square becomes limit z tends to 0. X is tending to infinity, z tends to 0. Limit z tends to 0 of 1 divided by root of 1 plus z. 1 divided by root of 1 plus z, and which is nothing but 1. Therefore, limit x tends to infinity of x divided by root of 1 plus x square is 1. Third problem, limit x tends to infinity log of tan 2x to the base tan x. Log of tan 2x to the base tan x. Here, limit x tends to infinity of log of tan of 2x divided by tan x can be expressed as, we know the formula, log of a to the base b is equal to log of a divided by log of b. Therefore, this can be expressed as limit x tends to 0 of log of tan of 2x divided by log of tan of x, which is infinity by infinity form, and hence applying L'Hospital rule, we will get limit x tends to 0 of log of tan 2x to the base tan x, log of tan 2x to the base tan x equal to limit x tends to 0 derivative of log of tan 2x divided by derivative of log of tan x, which is nothing but limit x tends to 0 of 1 by tan 2x into sec square 2x into 2 divided by 1 of tan x into sec square x. If you simplify this, you will get limit x tends to 0 tan x into sec square 2x into 2 divided by tan 2x into sec square x. Tan x equal to sin x divided by cos x. Sec square x is 1 by cos square x. And if you substitute these values here, you will get limit x tends to 0, 1 by cos 2x, and which is nothing but 1 by cos 0. Cos 0 is 1. Therefore, this is 1. Hence, limit x tends to 0, log of tan 2x to the base tan x is 1. Now, we shall see the problems of the type 0 infinity. 0 into infinity. What is a 0 into infinity form? As x tends to a, or x tends to plus infinity, or x tends to minus infinity, if fx tends to 0 and gx tends to infinity, then the product fa into ga is undefined and is said to assume the indeterminate form 0 infinity. This can be converted to the indeterminate form 0 by 0 or infinity by infinity by rewriting the functions. That is, fx into gx can be expressed as fx divided by 1 by gx, or fx into gx can be also expressed as gx divided by 1 by fx. And then we can apply L'Hospital rule. We shall see the example. Evaluate limit x tends to 1 log of 1 minus x into cot of pi x by 2. It is 0 into infinity form, and hence rewriting it in the form of infinity by infinity, it can be written as limit x tends to 1 of log of 1 minus x cot of pi by 2. X can be expressed as 1 of tan of pi x by 2, and it is infinity by infinity form. Hence, applying L'Hospital rule, limit x tends to 1 of derivative of log of 1 minus x divided by derivative of tan of pi x by 2. It can be expressed as limit x tends to 1 of 1 upon 1 minus x into minus 1 divided by sec square pi x by 2 into pi by 2, which can be rewritten as 1 upon sec can be written as cos. Therefore, this can be expressed as limit x tends to 1 of minus 2 cos square pi x by 2 divided by pi into 1 minus x. Now it is a 0 by 0 form. As it is 0 by 0 form, we shall apply L'Hospital rule. Limit x tends to 1 of minus 2 into derivative of cos square pi x by 2 divided by pi into derivative of 1 minus x, which is minus 2 by pi can be taken outside of the limit into limit x tends to 1 of 2 cos of pi x by 2 into minus sine of pi x by 2 into pi by 2 divided by minus 1. And derivative of 1 minus 6 is minus 1, which is nothing but 0. If we put x equal to 1, it becomes 2 cos of pi by 2 into minus sine of pi by 2 into pi by 2. And hence cos pi by 2 is 0, and hence this whole expression becomes 0, and hence limit x tends to 1 of log of 1 minus x pi x by 2 cot of pi x by 2 is equal to 0. Example 5. Evaluate limit x tends to a of a minus x into tan of pi x by 2a. This is 0 into infinity form, and hence we shall write this form as infinity by infinity form by writing limit x tends to a of tan of pi x by 2a divided by 1 upon a minus x. And as it is infinity by infinity form, we shall apply L'Hospital rule. Limit x tends to a of derivative of tan of pi x by 2a divided by derivative of 1 upon a minus x, which is limit x tends to a of sec square pi x by 2a into pi by 2a divided by minus 1 divided by a minus x square into minus 1. Simplifying, pi by 2a can be taken outside of the limit, and it becomes pi by 2a into limit x tends to a of a minus x square divided by cos square pi x by 2a. This is a 0 by 0 form, and hence it becomes pi by 2a limit x tends to a. Applying L'Hospital rule, derivative of numerator divided by derivative of denominator becomes 2 times a minus x into minus 1 divided by 2 times cos of pi x by 2a into minus sine of pi x by 2a into pi by 2a. Now, pi by 2a from numerator and pi by 2a from denominator get cancelled. 2 get, okay, and it remains limit x tends to a of 2 times a minus x divided by 2 times cos of pi x by 2a into sine of pi x by 2a, which is nothing but limit x tends to a of 2 times a minus x divided by sine of pi x by a. It is again 0 by 0 form. Therefore, applying L'Hospital rule, limit x tends to a into derivative of 2 times a minus x divided by derivative of pi x by a. It is nothing but limit x tends to a of 2 into minus 1 divided by pi x by a into pi by a. It is nothing but minus 2a divided by minus 1 into pi equal to 2a by pi. That's why limit x tends to a of a minus x into tan of pi x by 2a equal to 2a by pi. Next type, infinity minus infinity form. What is infinity minus infinity form? As x tends to a, or x tends to plus infinity, or x tends to minus infinity, if fx tends to infinity and gx also tends to infinity, then the difference fa minus ga is called as indeterminate form of the type infinity minus infinity. In such cases, we shall write the differences into a fraction of algebraic means. That is, fx minus gx can be written as 1 upon fx minus 1 upon gx divided by 1 upon fx into gx, which is 0 by 0 form. And then we can apply L'Hospital rule. Example 6. Evaluate limit x tends to pi by 2 of sec x minus tan x. Sec x minus tan x. This is infinity minus infinity form. Hence, we shall write it as limit x tends to pi by 2 of sec x can be expressed as 1 upon cos x and tan x can be expressed as sin x by cos x. It becomes limit x tends to pi by 2 of 1 minus sin x divided by cos x. This is a 0 by 0 form. And hence, applying L'Hospital rule, limit x tends to pi by 2 of derivative of 1 minus sin x, which is minus cos x, and derivative of cos x is minus sin x, which is cos pi by 2 divided by sin pi by 2. It is 0. Example 7. Evaluate limit x tends to 1 of x divided by x minus 1 minus 1 upon log of x. It is infinity minus infinity form. Hence, it can be expressed as limit x tends to 1 of x log of x minus x minus 1 divided by x minus 1 log of x. It is a 0 by 0 form. And hence, by using L'Hospital rule, we shall write limit x tends to 1 of derivative of x log of x minus x minus 1 divided by derivative of x minus 1 log of x. It is limit x tends to 1 x log of x. We shall use here UV rule. X as it is into derivative of log of x is 1 by x plus log of x as it is into derivative of x is 1 minus derivative of x minus 1 is minus 1 divided by x minus 1 into 1 by x plus log of x into derivative of x minus 1 is 1, which can be expressed as limit x tends to 1 of 1 plus log of x minus 1 divided by x minus 1 into 1 by x plus log of x. After simplifying, we will get limit x tends to 1 log of x divided by x minus 1 into 1 by x plus log of x. It is 0 by 0 form, and hence again applying L'Hospital rule, we will get limit x tends to 1, derivative of numerator 1 by x, derivative of denominator is 1 by x plus 1 by x square, which is equal to 1 divided by 1 plus 1 equal to 1 by 2. Example 8. Evaluate limit x tends to 0, 1 by x square minus cot square x. Here, limit x tends to 0, 1 by x square minus cot square x can be expressed as cos square x divided by sin square x. And simplifying, we will get limit x tends to 0 of sin square x minus x square cos square x divided by x square sin square x. And it is 0 by 0 form. For simplifying, it can be expressed as sin square x minus x square cos square x divided by x raised to 4 into x square divided by sin square x, multiplying and dividing by x square. And separating the limit x tends to 0 of sin square x minus x square cos square x divided by x raised to 4 into limit x tends to 0 x by sin x square. We know that limit x tends to 0 of x by sin x equal to 1. Therefore, it remains limit x tends to 0 of sin square x minus x square cos square x divided by x raised to 4, and it can be expressed as limit x tends to 0 of sin square x divided by x square into 1 by x square minus cos square x divided by x square, separating the terms. And again, we know that sin x by x, limit x tends to 0 of sin x by x is 1. That's why it remains limit x tends to 0 of 1 by x square minus cos square by x square, which is nothing but limit x tends to 0 of 1 minus cos square x divided by x square. But 1 minus cos square x equal to sin square x. Therefore, this becomes limit x tends to 0 of sin square x divided by x square, which is 1. And hence, limit x tends to 0 of 1 by x square minus cot square x is equal to 1. Now, another forms 0 raised to 0, infinity raised to 0, 1 raised to infinity. As x tends to a, or x tends to plus infinity, or x tends to minus infinity, the expression fa raised to ga is said to be indeterminate form of 0 raised to 0 if fx tends to 0 and gx tends to 0. It is called as indeterminate form of the type infinity is to 0 if fx tends to 0 and gx tends to 0. It is also called as indeterminate form of type 1 raised to infinity if fx tends to 1 and gx tends to infinity. While evaluating such types of forms, we shall assume that yx equal to fx raised to gx. Then take a logarithm of both sides, that is a log of y is equal to g of x into log of fx, which is of the form 0 into infinity and can be evaluated as the problem solving by the form of 0 infinity. Taking limit as x tends to a, we will get limit x tends to a log of y equal to k suppose. Therefore, k equal to limit x tends to a of log of y. Interchanging log and limit, log of limit x tends to a of y equal to log of limit x tends to a of fx raised to gx, and hence limit x tends to a of fx raised to gx equal to e raised to k. Here, Maclaurin series expansion may be used for simplifying expressions. Also, some standard limits also use, that is, limit x tends to 0 of sin x by x equal to 1, limit x tends to 0 of tan x by x equal to 1, limit x tends to 0 of 1 plus x raised to 1 by x is 1. We can use these rules also. 0 raised to 0 type. Example, evaluate limit x tends to 0 of x raised to x. This is a 0 raised to 0 form. Therefore, take y equal to x raised to x. As y equal to x raised to x, take logarithm of both sides. Log of y equal to x into log of x. Limit x tends to 0 of log of y equal to limit x tends to 0 of x log of x equal to limit x tends to 0 of log of x divided by 1 by. This can be written as limit x tends to 0 of log of x divided by 1 by x. As x tends to 0, log of x tends to infinity, 1 by x tends to infinity. Therefore, this is infinity by infinity form. Here, we apply by L'Hospital rule. By applying L'Hospital rule, we will get limit x tends to 0 of derivative of log of x is 1 by x, derivative of 1 by x is minus 1 by x square, which is nothing but limit x tends to 0 of minus x, and it becomes 0. Limit x tends to 0 of minus x, which is 0. And therefore, limit x tends to 0 of log of y equal to log of limit x tends to 0 of y is 0. Therefore, limit x tends to 0 of y equal to e raised to 0, which is 1. And that is nothing but limit x tends to 0 of x raised to x equal to 1. Hence, the answer of this problem is 1. Example 10. Evaluate limit x tends to infinity of e raised to x plus x raised to 1 by x. Consider limit x tends to infinity of e raised to x plus x raised to 1 by x. Suppose this is equal to y. E raised to x, suppose e raised to x plus x raised to 1 by x equal to y, as it is infinity raised to infinity 0 form. Infinity raised to 0 form, and hence we shall assume that e raised to x plus x raised to 1 by x equal to y. Taking log of both sides, log of y equal to log of e raised to x plus x raised to 1 by x, which can be written as, and taking limit x tends to infinity of log of y equal to limit x tends to infinity of log of e raised to x plus x raised to 1 by x, which can be written as limit x tends to infinity of 1 by x log of e raised to x plus x. That is nothing but limit x tends to infinity of log of e raised to x plus x divided by x, which is infinity by infinity form. And hence, by applying L'Hospital rule, we can get limit x tends to infinity of derivative of numerator divided by derivative of denominator. That is nothing but limit x tends to infinity of derivative of log of e raised to x plus x is 1 upon e raised to x plus x, and derivative of e raised to x plus x is e raised to x plus 1 divided by derivative of x is 1. Therefore, this can be written as limit x tends to infinity of e raised to x plus 1 divided by e raised to x plus x, which is again infinity by infinity form. Hence, we shall again apply L'Hospital rule, which is nothing but limit x tends to infinity of derivative of e raised to x plus 1 is e raised to x, derivative of e raised to x plus x is e raised to x plus 1, and which is again infinity by infinity form. Hence, again applying L'Hospital rule, we will get limit x tends to infinity of e raised to x divided by e raised to x, which is 1. That is limit x tends to infinity of 1, and we will get final answer 1. Therefore, limit x tends to infinity of log of y equal to 1. But limit x tends to infinity of log of y is nothing but log of limit x tends to infinity of y. Therefore, log of limit x tends to infinity of y equal to 1, and hence limit x tends to infinity of y equal to e raised to 1, which is e, and hence limit x tends to infinity of e raised to x plus x raised to 1 by x equal to e. Dear friend, if you are new to this channel, please subscribe the channel and don't forget to press bell icon so that you can get updates of this channel. Thank you. See you in next video.